Let's look at these matrices. So I'll assume not everybody's familiar with working with them. First thing we need to just kind of recall, we're going to do matrix multiplication. That's what we're focusing on today. And when we do matrix multiplication, it's a row by column multiplication process. I'll show you what we mean by that in a second. But we'll take the rows of one matrix and multiply them down the column of another matrix. All right. So when we start to label these matrices, you got to make sure you understand how we're reading these. So this first box right here is a matrix, and it is a 2 by 2 matrix. The number of rows always comes first, and then it's by the number of columns. And so a lot of people get caught up, or I can't remember which is first, or how do I remember? Well, when you look at this matrix, obviously the rows go side by side, but I think about what's a column in like real life. So in a building, what does a column look like, or what does a column do in a building? It supports it, right? So I think at the attendance office, when they first built the school, they didn't have those big old columns out there, but they put them out there a couple years ago, and they're there for visual purposes, but it's a structural piece. So I just remember that columns are big old brick or stone that helps keep up the building. So columns go this way outside by the attendance office. Same thing here. A column is up and down. So this matrix has 2 rows. It's 2, and then it has 2 columns. So it's a 2 by 2 matrix, which we call a square matrix. But just understand columns are up and down, rows are side to side. So when we do matrix multiplication, whatever matrix comes first, you're going to work your way across the row, and you're going to combine it with elements down each column. So if we focus on this first row and this first column, which I'll call row 1, column 1, we will combine all of the terms to get our new elements, which we call the resultant or the resulting matrix. You might see this word sometime, resultant, for the resulting matrix. It's basically like the solution matrix. Okay, so in the process, we would do A times E. That gives me my first piece of this new element. And then I work my way across the row to B as I go down the column. So my next piece, and I would always add these together, will be B times G. I'd multiply these two numbers together, add them together, and I would get my new element. Okay, it's a little weird when we're doing letters, but these will be numbers, so don't start thinking you're going to have to be doing algebra and solving like this with these. These will just be numbers, but this is how this process is going to work. How about we just go ahead and get to it, and I will show you. Once you get it, it's not hard. Just one of those things you got to be organized with. All right, so we're given 2 matrices. We got 2 square matrices. This is a 2 by 2 matrix, and we'll multiply it to matrix B, which is also a 2 by 2 matrix. All right, so we want to find what A times B is. Since A comes first, we're going to work our way across the rows of A, and we're going to combine it as we go down the columns for B. All right, so we start on the first row, and we multiply it by elements from the first column. So my first piece will be 2 times 0. And then I'll work my way across as I go down, and I will add all these together. So I go to the next element, which is 3, and I'll multiply 3 by the next element as I go down the column, which is 5. So 3 times 5 gets me my next piece. Okay, and then how about I go down a row? So my next combination will be row 2, and then I'm still at the first column. So I've got 4 times 0 plus the next number in the row, which is 7, times the next number in the column, which is 5. 7 times 5 is, I forgot I'm writing all of it out. 7 times 5. Right, so next I need to come back up. I'll go back to the top row, but this time I need to do the second column. So I'll combine row 1 with column 2. So I've got 2 times 1 plus 3 times what? 6. Yep. Next element is 3 here. Next element is 6 there. So 3 times 6. All right. Now I'm at the go down a row. So second row, second column. What's my first combination? 4 times 1 plus what? 7 times 6. I go to the next piece of the second row, and then I do the next piece of the second column. So 7 times 6. Right. You got any questions where these combinations are coming from? Row 1, column 1, row 2, column 1, row 1, second column, second row, second column. Now let's see what these actually come out to equal. 2 plus times 0 is 0, plus 3 times 5 is 15. What's 0 plus 15? 15. Next I've got 0 plus 7 times 5 is 35. 0 plus 35 is 35. This next spot we have 2 plus what, 18? What's that result? 20. Then last spot we've got 4 times 1. 42. Yep, plus 42. 4 plus 42 is 40, 46. So this is our answer, what we call our resultant matrix. Okay, so this multiplying process, we go across the rows and combine them down the columns. If this was B times A, it would be a completely different answer because we would go across B and then times A. So what you put first does matter. One question might be A times B, the next question might be B times A. It could be a completely different answer. Who knows? You might coincidentally get the same result, but it's not the same process. Right? You guys got any questions? So how about you guys go below and take a second, see what you can come up with on your own. We're still doing A times B, but we have different pieces in each of the elements. So remember, you're going across the row and then you're going down the column. And so as you start to get used to this, you won't have to write everything out. For instance, I would do 1 times 4 is 4, and then 3 times 1 is 3. I like to just go ahead and write it like that. Some of y'all might be able to do it all mentally, but I know I make mistakes when I do too much stuff mentally, so I like to write down. All right, anybody else get this? Okay, got any questions? All right. So remember, it's rows times columns. So for each one of these cases, we had a 2-row, 2-column times a 2-row by 2-column matrix. And our result was a 2-by-2 matrix as our result. So we had square matrices we multiplied together. Now, not all matrix combinations can be multiplied together. They need to have matching elements in a sort, because you wouldn't want to have like 1, 2, a third piece right here and only match it up with 2 pieces, because that couldn't work. So you can't always multiply 2 given matrices together. They need to have a common something I will try to get to. All right, so you have your first matrix, you have your second matrix. The inner numbers need to match in order for you to be able to multiply the 2 of them together. So for instance, here we had a 2-by-2 times a 2-by-2. Since the 2's were the same, the inner pieces were the same, we could multiply them together. To give you another example, maybe we have a 4-by-3 matrix, not 4 plus 3. We have a 4-by-3 matrix, and we wanted to multiply it to a 3-by-5 matrix. The question would be, can we do that? The answer is yes, because we've got 3's for the inner terms. It doesn't matter that the matrix are of different dimensions. What matters is the columns here have to match up with the rows here, if that makes sense. Okay? If you got something that was maybe 3-by-5 and a 4-by-2, if we swap them, well, we can't do that. So you wouldn't be able to multiply the 2. All right, and then also interesting, when we can multiply these matrices, the resulting answer matrix will always be the combination of the 2 outer terms. So if we were looking at this setup and we had m by n and n by p, the middle ones match, the result would be the first number by the second number. So in this case, our resulting matrix would be a 4-by-5 matrix for our answer matrix. And that's nice to know, because as you start to work it, you will want to say like, this feels wrong, like how am I getting a 4-by-5? But as you start to do it, you'll naturally get 4 rows, 5 columns, and you'll say, okay, this is all matching up. And it just kind of verifies that you're doing the right things you should be. So before you start to multiply 2, especially when they're not just square matrices, you need to check to make sure you can actually multiply them together. And if you can't, it's not your fault, you just can't do it. So it would be no result or cannot be determined matrix. All right, so let's look at 2 new ones, and let's try to multiply them together if we can. Okay, so matrix A. How many rows are in matrix A? Yep, 1 row going across. How many columns? 1, 2, 3 columns. Remember, columns are up and down. So this is a 1-by-3 matrix. Make sense? How many rows are in B? 1, 2, 3. Remember, rows are this way. 1 row, 2 row, 3 rows. How many columns? 1 tall column. So we got a 3-by-1, a 1-by-3 and a 3-by-1. Can we multiply A times B? We can. We got a 1-by-3 and a 3-by-1. Since the inner numbers match, we can do it. What will the resulting matrix be? 1-by-1. Ready to do it? All right, let's do it. Start off with A, and I've got 1 times 4. I don't know why I wrote it so big, but that is 4. What's next? 2 times, well, remember, I'm working across this row as I go down this column. First I did 1 times 4, and then I'll move to the next element, which is 2 times 5. What's 2 times 5? 10. And I'm not finished with my combinations yet. August, I'm not finished. All right, so I have 3 times what? 6, which is 18. Let me add these all together. 10 and 8 is 28. And then 4 plus 28 is 32. So my resulting matrix is just 32. And notice that is a 1 by 1 matrix. It's got 1 row, it's got 1 column. All of this should be kind of adding up. Feel okay about that? Can we change the order and do B times A? Yes, I talked about that earlier. You can't swap it and get the same thing. And this will prove that you can't swap it and get the exact same thing. Okay, so the answer is yes, we can do it. If we went to do B and A, B is a 3 by 1, A is a 1 by 3. Since the ones match, we can do it. What will the result be? 3 by 3. The outer numbers are the resulting matrix. So our answer should be a 3 by 3 matrix. Interesting. Let's see how that's going to work out. Now, me personally, my brain, I make mistakes if I try to mentally put B in front and A after it. So I like to rewrite them when the order's swapped up. But some of y'all's brains are pretty sharp, so you may be able to crisscross. I just make mistakes when I do that. So I'm going to rewrite B so I see it in front. I'm just going to rewrite it. Or maybe you just need to write A over here. I'll just go ahead and rewrite the whole thing. And then matrix A is 1, 2, and 3. Okay, so we're going to go across matrix B this time, and we're going to go down the columns of matrix A. Everybody okay with the plan? All right, you guys feel free to take a second and work through it if you want, or you can follow along with me. So, first row, first column, gives me 4 times 1, which is 4. Now, there's nothing else to go to next here, and there's nothing else to go down to here. So I'm done with that one spot. That's going to happen for all of them. There's only one thing to do for each location. Okay, so doesn't matter where you go next. Maybe just be consistent with yourself. If you want to go and do the first column first, that's fine. Or if you want to do the first row first, that's perfectly fine. Just maybe pick what you want to do and just be consistent so you won't confuse yourself. So I'll go to the next row. Second row, first column. 5 times 1. Next row, third row, first column. 6 times 1. Now I've got the first column complete. All right, let's go to the second column. So back at the first row, second column this time. 4 times 2. 5 times 2. 6 times 2. Got the second column. I've got one more column where the 3 is. I'll go back up to the first row. So first row, third column, 4 times 3. 5 times 3, 6 times 3. Sure enough, we got a 3 by 3 matrix as my result. Resultant matrix. Right, making sense? Anybody got any questions? Okay, so check it before you start trying to do it. And if you forget to check it and you can't do it, you will run into problems and you'll realize that you can't do it because the dimensions don't match up like they should. All right, so how does this get harder? Well, the matrix just get bigger. Maybe the numbers are negative, so I know that's a hurdle for some of us, but that's really the only way it gets harder. So let's look below. Last example, and then we'll look at some matrix equations, solving those. All right, so we want to find the product. It didn't give us A and B, it just kind of set the matrices up for us. Let's see, this first matrix has how many rows? 2, and then how many columns? So it's a 2 by 2. The next matrix has how many rows? 1, 2, good job. By how many columns? 4. 1, 2, 3, 4. Can we do it? Yes, we can. The 2's match. So you guys take a second and multiply these 2 together. Our result will be a 2 by 4 matrix. So I'm going to go across the middle. 4 times 1 plus 4 times 0. Now go next row. 1 times 1 plus 3 times 0. Second column, 4 times 2, 2 times 2. Second row, second column, 1 times 2, 3 times 2. All right, third column here, first row at the top, 2 times 3. Next element is 2 times negative 1. And you could do plus negative 2. I'll just go ahead and do minus 2 because this is negative. Second row, third column, 1 times 3. 3 times negative 1. Top row, last fourth column, 4 times 4, 2 times 6. Then I'll go down to the second row, fourth column, 1 times 4, and then 3 times 6, which should be 18. Got any questions? All right, let's add them up. First result is 4. If I go down to the next row, we get 1. First row, second column, first spot is 12. What's right below it? 8. What's right next to it? 10. What's next to that? 28. Good job. If I go back, what's below 10? 0. And then bottom right, 22. You feel like we know what we're doing? It's not difficult, it's just kind of tedious. Can we multiply the next 2 together? Let's see, 2 rows, 1, 2, 3, 4 columns, and then we got a 2 by 2 square matrix here. So 2 by 2. Can we do these? No, we cannot do these. So we just say, can't multiply. And that will be it. Can't do anything with it. I think the former math term to it is indeterminate or something like that, but you can't multiply. Can't multiply these together. Right? I got another example if you guys want to do it. I don't mind at all. But if we feel like we got it, then we can just keep going. I don't mind either way. Y'all want to do one more? You do? Okay, we can do one more. No problem at all. How about you guys take a second and you guys try to go through this. The dimensions are the same. 2 by 2 and 2 by 4. So we should be able to do this. Second ones we can't do. 2 by 4 and then a 2 by 2. And just to show you why we can't do it, as we start to work our way across this row and down this one's columns, we would have 2 times 1, and then we would go 3 times 0. But when I got to -1, I would be looking for some number here, but I've ran out of numbers. So we just can't, there's nothing to do. Then when I go to 6, I would be looking for something here. There's nothing here. So it just doesn't match up and we won't be able to do it. But that's why you can't multiply these together. It doesn't all line up. But you guys take a second and do A. See what we come up with. Let me know if you get stuck or got a question. See, 1 times 2 is 2. 3 times 0 is 0. Next row, 0 times 2 is 0. 2 times 0 is 0 as well. Second column, 1 times 3 is 3 plus 3 times 5, 10. Second row, second column, 0 times 3 is 0, and then 2 times 5 is 10. Third column, back at the top row, 1 times -1, 3 times 4. Go down to the second row, third column, 0 times -1, 2 times 4, then I'll go back to the top row in the very last fourth column, 1 times 6, 3 times 1. Then second row, last column, 0 times 6. 2 times 1. Yeah, add them all up. All right, got any questions? Okay, so whatever comes first, work your way across the row. Whatever matrix comes second, go down the columns. Make sure you check to see if you can actually multiply them together before you start doing it, just to save yourself a little headache. But like I say, if you try to multiply them together, it just won't work out if you forget to do that. Matrix multiplication. All right, so now that we got the skills to be able to do some matrix multiplication, we can kind of use this to solve matrix equations. And it basically kind of works the same way as a normal equation. We're just working with matrices, so we got to remember that as we go along. Now, these equations aren't meant to be like big, long equations. I think of it as kind of like a puzzle where you're looking for the mystery matrix X. What does matrix X need to be to make this statement true? You'll be given all the matrices that you need except for one, and that's the matrix that you want to try to figure out for. So we're given a matrix A and a matrix B, and we want to find out what matrix will we need to multiply by 4 and then subtract by A to get matrix B. What we'll do is solve this matrix for X, and then we'll know exactly what we need to do to get this missing matrix. All right, so just like a normal equation, let's solve this for X. What would you subtract from, add to both sides first? Matrix A, we need to add it to both sides, so let's do that. And so that gives me 4X equals matrix A plus matrix B. And to get X by itself, what would I divide both sides by? 4. Divide both sides by 4. And we see what matrix X equals. It's a little bit easier if we just write it in a little bit different way, because again, this is an operation we're going to do on some matrices. So we've got X by itself. Matrix X will equal. And instead of saying to divide both of these by 4, I'm just going to write, let's multiply both by 1 over 4. This is the same thing as dividing by 4, right? And then we'll have to still do matrix A plus matrix B. So now that we've got it solved, we can do operations on everything on the right, and our result will give us what the missing matrix is that we're looking for. So we got 2 things we need to do. First, we need to take matrix A and add it to matrix B, just like to do now. And then we'll take that result and just multiply everything by 1 over 4. The answer that we get will be what the missing matrix needs to be. Does that kind of make sense? So first, let's add the 2 matrices together. Matrix A plus matrix B. It's like step 1. You guys take a second and do that real quick, just like to do now. You just go spot for spot. You don't do the cross multiplication or anything like that. Although we could if we needed to, but we don't have to do that for this. What's the top left? 2 plus 6? What's below it? -2. What about top right? 4. What about bottom right? Negative 12. Right, so we added the two together. Any questions? Okay, and now, last step to figure out what matrix X needs to be, we just need to multiply 1 over 4 by it. So, we'll do 1 over 4 times the result we just got. You might have gotten enough space here. I didn't really give myself enough space, so let me rewrite what I got for A plus B. And I just need to pretty much divide everything by 4. So it'll be 8 over 4. Multiply negative 2 by 1/4, which gives me negative 2 over 4. 4 over 4, and it'll be negative 12 over 4. So we call this is like a scalar multiple. We just changed the scale of our matrix. We made the numbers smaller by 4. We scaled it down by 4. It's a scalar multiple. Right, so our result, which will be matrix X, is 8 divided by 4 is what? 2. What can we reduce negative 2 over 4 to? Negative 1/2. Good. 4 divided by 4? 1. Negative 12 divided by 4? Negative 3. So this was that missing matrix that we had. And basically what this means is, if we take matrix X, we multiply it by 4, and then if we subtract A from it, we'll end up with matrix B. So we kind of work backwards by solving it to figure out what we need to do with what we know to get this missing matrix. Okay, if you are interested and you have some time, you might put it back in here and then see if it actually works out the way it should work out, which it should. It should. You guys got any questions? All right. So matrix multiplication and then solving matrix equations. That was our goal for today. We got an Alex where we're just practicing this a little bit. And then this unit, we only got a short unit. We'll do one more section in this unit where we look at how this helps us solve equations and system of equations, which is going to be a whole lot more easier than probably the ways that you know how to get these solved. We just needed these skills to be able to do it. And then next class, instead of like having a test on this unit or a quiz, you guys will do like a group activity, and that'll be like our summative assessment for this unit, because it's pretty short. So the group activity will be kind of like a quiz grade. We'll talk about that next class. But you guys practice these skills on Alex. Let me know if you need any help with any of this stuff. And then if you were out yesterday and you want to go ahead and take the quiz, the test we took yesterday today, we can do that. Or let's talk and get a time where we can make up the test if you haven't did it yet. Anybody got any questions? All right. Let's get our Alex done, and let me know if you need any help with any of this stuff.